Okay, this is another problem still on binomial theorem, and it says that 9 plus x, square root of 9 plus x squared, that we should show that the square root of 9 plus x squared is approximately equals to 3 plus 1 over 6x squared minus 1 over 216x raised to the power of 4. For what value of x is the expansion valid? So let's start. So let's open this bracket. What this one means is the same thing as 9 plus x squared raised to the power of half. That is what this statement means. Now, half, that's our n. Our n in this case is less than 1. So if we are dealing with, if n is less than 1, if n is less than 1, if a plus b raised to the power of n, if our n, the expansion will be a raised to the power of n plus n into a n minus 1 to b plus n into n minus 1 all over 2 factorial we have a n minus 1 then d squared. So you also have n into n minus 1 all over 2 factorial. So we have a n minus 1 minus 2, sorry, then b squared plus n into n minus 1 n minus 2 all over 3 factorial n minus 3 then b raised to the power of 3. Then we have continues like that. If your n is infinite terms, we're going to get. So we have this term. That would be the pattern if our n is less than 1. So we are going to expand this now. Now, the first thing you need to do is to ensure that this 9 becomes 1. And you're going to see how I'm going to turn this 9 to become 1. So, because it will help us in simplifying the problem that we are trying to solve. It's important you turn this one to 1, the first term there to 1. If it's not 1, find a way to force it to become 1. So we are going to have 9 in bracket. So I'm factorizing 9 out. That will be 1. This will now be x squared over 9 all raised to the power of. Okay, let's do it like this. All raised to the power. Let me clean this. To the power of half. This is this statement. So 9 times 1 will give us 9. And then 9 times x squared over 9, it will give you x squared. So invariably, you have turned this man. It was 9 here before. You have found a way of turning it to be 9, to be 1, without altering the question. So this one now becomes 9. So you now have half x squared over 9 so you have this. So this one, 9 raised to the power of half is 3. So I copy that and paste it. So we can now start this problem. to solve this problem. So I can say 3 in bracket. Now we're going to follow this formula. We have 3. Now we're going to follow this pattern in order to expand this one. So we now have 1 raised to the power of 1 over half plus the next one is half. So we have 1 raised to the power of half minus 1. I would have omitted that one out, but I want you to see what we are expanding. That's why I'm writing out that 1 raised to the power of everything. In normal case, you just leave it, omit it, because 1 raised to the power of anything will always give you 1. So, but for the sake of our class, for this video, I'm going to be expanding normally as if I'm explaining to a layman. So we now have x squared over 9. So the next thing, we have half into half minus 1 all over 2 factorial. So I will now have 1 raised to power of minus 2. Then we have this man, x squared over 9 all squared. Now look at the question that we are given. I want you to look at the question we are given. The question we are given, this is raised to power of 4. So by the time we expand this x squared, by the time you expand this x squared raised to the power of to become x raised to power 4. So that means we can stop here. We can stop there and leave the rest terms. So we can stop there for the sake of the term we are asked to find. So this one becomes 3 in bracket. So we have 1. By the time we open up this bracket, this becomes half. Then you have x squared over 9 plus half minus half over 2 over 2. So you now have, open up this bracket, that will give us x raised to power of 4 all over 81. Bracket close. So dash dash dash. So we can still work on this. So 1. So in that place we have x squared over 18. Then this other one will give us minus 1 over 8 over 8 into x raised to power of 4 all over 81. So we have that. So I'm still going to, since I've so dash dash dash, I need to change something things in. need to change this. So now we are pausing it now. So we have that. So now let's expand more. So you have 3 plus, this will now be x squared over 6 plus 3 will go in that one, 27. 27 times 8. I need to use my calculator. 27 times 8, that's then 27 times 8, that's 216. So what we have there is minus x raised to power, 1216 x raised to power of 4. So this is what we are going to get for this expansion. So you can look at it, you can see that this is what we have for the expansion. So the next part of the question says that for what value of x is the expansion valid? So we need to, that is quite simple. So just imagine that we have x, absolute x, absolute x squared, because that is squared. X squared is less than 3, than 9. So less than 9. So now what you just need to do is just find the square root of that. So you just have, let me just copy this. So by the time you find the square root, so let me just remove this. So you have 3 there. So this will be 3. So the expansion is valid. So I'm going to copy this. So don't worry. So what value of x is the expansion valid? So it will be valid at when x, absolute x squared, is less than 9. So when x is less than 3, absolute x is less than 3. So that is how to go about that problem. So I hope you enjoy solving this particular problem. So this is how to go about this. So we'll come back again, solve another problem still on binomial theorem. So you can come back again and watch the next video, still solving binomial theorem problems. So thank you for watching. Please don't forget to like, to share, and to subscribe, to share our videos, to like our videos and subscribe to it. Thank you.